Hi everyone, I am Jyothisha. Today I am going to explain about quicksort. Firstly, quicksort is the fastest known sorting algorithm in practice. There are average cases and worst cases, but the worst case can be made exponentially unlikely. Another divide and conquer recursive algorithm, like merge sort. The main idea of quicksort. Quicksort is a divide and conquer algorithm. It picks an element as a pivot and partitions the given array around the picked pivot. There are many different versions of quicksort that pick pivot in different ways. Always pick the first element as a pivot, always pick the last element as a pivot, pick a random element as a pivot, pick median as a pivot. First, you need to select a pivot. Let us select 65 as a pivot. And after selection, we divide other elements into two other groups and pivot is treated as another group. After that, we try to arrange elements of other two groups in increasing order and the pivot is compared to each and every element if it is greater or lesser than the compared element and placed accordingly. Partitioning strategy. For now, assume that pivot equals A of left plus right by 2. We want to partition array, that is A of left to right. First, get the pivot element out of the way by swapping it with the last element. Let I start at the first element and j start at the next to last element. When I is less than j, move I towards right, skipping over elements smaller than the pivot. Move j towards left, skipping over elements greater than the pivot. When both I and j have stopped, a of I and a of j should now be swapped. When I and j have stopped and I is to the left of j, swap a of I and a of j. That is, the large element is pushed to the right and the small element is pushed to the left. After swapping, a of I is less than or equal to pivot and a of j is greater than or equal to pivot. Repeat this process until I and j cross. When I and j have crossed, swap a of I and pivot. And the final result is a of k less than or equal to pivot for k less than I and a of k is greater than or equal to pivot for k greater than I. While picking the pivot, choose a pivot so that we will get two partitions of almost equal size. There are different ways for picking the pivot. Use the first element as a pivot or choosing the pivot randomly. Choosing the pivot randomly is generally safe, but random number generation can be expensive and does not reduce the running time of the algorithm. And the other way is that median of 3 partitioning. This eliminates the bad case for sorted output. It reduces the number of comparisons by 14%. In median of 3 method, compare just 3 elements, the leftmost, the rightmost and the center. Swap these elements if necessary so that U of left is smallest, U of right is largest and U of center is median of 3. Pick U of center as the pivot. Swap U of center and U of right minus 1 so that the pivot is at the second last position. This is an example for median of 3 sorting. Small arrays. Do not use quicksort recursively for small arrays. Use a sorting algorithm that is efficient for small arrays, such as insertion sort. When using quicksort recursively, switch to insertion sort when the subarrays have between 5 to 20 elements. 10 is usually good. It saves about 15% in the running time and it avoids taking the median of 3 when the subarray has only 1 or 2 elements. This is the code for quicksort of choosing a pivot, partitioning, recursion, and for applying conditions. The partitioning code we just saw works only if pivot is picked as median of 3. Now let us see some of the assumptions. First, pick a random pivot. Second, no cutoff for small arrays. Third, if the number of elements in S is 0 or 1, then return, that is to base case. Finally, pick an element V in S, called as the pivot. What will be the worst case? The pivot is the smallest element for all the time. Partition is always unbalanced. Now what will be the best case? Partition is perfectly balanced. Pivot is always in the middle. This recurrence is similar to the merge sort recurrence. And this is the average case analysis. Thank you.